But how you guys doing? You're feeling good? Kind of last session on a Friday, so I'll try to keep it short and sweet, keep you guys awake. My name is Aaron Minier. I'm the Director of Web Development at Isovera. We're a Drupal shop based in Waltham. We're semi-virtual though. Work with a range of clients, e-commerce, high-tech, public media, nonprofits, and others like that. But I'm not here to talk about Drupal today. I'm just going to be talking about Git. And it's a tool that I would say we may actually use even more than Drupal at Isovera. So before I go any further, I just want to get a sense of where everybody's at here. So can you just raise your hand if you use Git as part of your daily routine? It's something you're always using. Okay, so a few people. Is there anybody who has not used Git before here? Okay, good. How many of you have used GitHub? Good. Regularly, or just a few times? Okay. How many of you have used the rebase command? Couple. Cool. So I think you're pretty much at the right session here. Part of my job is to do code review and integration of Git commits using GitHub and other repositories. But so I'm looking at a lot of commits and trying to make sense of them, track down changes. Commit messages are really important to me. It's a little dark, but I don't have. This is kind of a interesting website. It's a little dim here.
I turn off one of these lights with it.
Well,
how about that?
Should brighten up a little bit here. Okay, so we'll see how this goes with the screen. Okay, so this is a Git comment generator. This is live. I didn't write these, so I don't know what we're gonna get. But I don't know if that's, I guess, a Python script. Some, not terribly useful messages here. That one worked pretty well, I guess. Yeah. How many of you have seen or written commit messages like this? Just raise your hand. So one of the things I want to emphasize today is the importance of writing good Git commit messages. First off, you start with a one-line summary, and you want to write that generally in the imperative mood. So like a command of update this particular file or change the README documentation or something like that. No period. In 50 characters or less, nice and succinct. And if you're using an issue tracker, reference that relevant issue number. Then followed by a longer description if necessary. And what you want to be doing is explaining the what and the why, really, of this commit. The how, like what it's actually doing, is in the diffs, in the files themselves. You can use the tool to actually see that content. You don't have to write messages that explain what you did. What was this actually trying to do on the site or wherever you're using it for? So yeah, and then also the descriptions of 72 characters. So kind of a technical thing, but and kind of a stickler thing, but actually really important. And I think that the GitHub, that's right. So the GitHub commit message user interface it's a really kind of model lesson in how to write do a user interface, because it has a kind of a example default. So this is for editing a README file, right, on the site, directly on GitHub. It has the placeholder text to, and actually, I think if you don't even write anything, it'll use that message. But to kind of model how to write that imperative mood and keep it short, And then in the following lines, you can add plenty of text there. So kind of a minor thing. It's simple, but you just got to follow it. And then as those, this might look familiar to you, Chris. So as those commits start to add up, you'll see a commit history that looks something like this. And the way that GitHub displays that is really handy. And you can see that if you follow that consistent structure, you get this really nice way to, you can scan through those commit messages pretty easily. And then on GitHub, you have these like little ellipses here, the ... that you can click on and get more information and see that extended description right there. So that can be a really informative way to look through your issue queue. And I mean, so like I said, why bother? So you can just look at it really quickly and just scan and see it where your changes were. Locally with the git log command and on GitHub or whatever repository you're using. It helps others to understand and locate those relevant changes that you've made using the log and maybe the grep command to search. Using the bisect command, it will help you to track down and find bugs. When you do a reverse commit, that same commit message will be applied, but we'll say reverted in that commit message so that that same text is useful again. And also if you merge it, if you move that commit to a different branch with cherry pick, it's going to be the same commit message. It's kind of like a nice little package that can move it around. So also, maybe this is the most important thing, I think, to me. Like, it's just you get this kind of feeling of satisfaction when you write a good commit message. You're describing the work that you did, and you can go back and look at it and feel some satisfaction with your work. So I think the big takeaway for this session I want you to have is commit frequently. And think of committing as file save. If you haven't committed, then you don't think of that work as saved. And commit precisely. Commit changes in a meaningful way that you're not just like adding a directory where so you're going in and working on a lot of different things and then just adding that in bulk and then writing your message some stuff, right? You want to be able to commit very clear, like very simple and kind of atomic so that each file that's in that commit is relevant to that commit message. So just kind of talking about like coming into using Git. So I started with CVS years ago, and when I first used a version control system with CVS, my supervisor said, you have to like check in all this work that you did, just go do it. And I said, well, do I really have to? And I kind of resisted for a while. Then I'm like, oh, fine, I'll use it. And then I just was like, just dumping stuff into a drawer, right? Like it was useless to me. It was just something I had to do. Later on, I started to use Subversion on a project. The project manager introduced it. And it wasn't as bad as CVS, but it was still kind of a nuisance to me. It didn't really, as a developer, do anything for my work. It was more like in case anything went horribly wrong. It was just sort of an obligation of the job. And it was, like I said, it was kind of annoying because you had to use subversion commands to like rename directories, move directories and files. If you didn't, maybe not moving files, but you have the recursive subversion stream. So anyway, I won't pile on the subversion, but my point is that once I started playing around with Git and working in a local repository, it was like revelation because this is actually useful to me as a developer, like immediately, tangibly useful. Working on the code that I'm actually working on, not just in terms of trying to figure out like what the bug was like 2 months ago, but actually helping to like look at changes as I'm working on the file. And also, it's just really easy to commit and push at my leisure. And sometime last year, one of my colleagues, Ramy Denton, introduced interactive rebasing to me, and I started. At first, I thought it was like this arcane kind of command that I don't, maybe it was for like Linux kernel developers, and I wouldn't really need it. But once I started experimenting with it, I found that it was like the same experience as starting with Git coming from Subversion. It gave me this ability to like really just focus on the coding and then commit like very frequently, like every few minutes or sometimes seconds. And then I could come back and revisit that code and deal with it later. So I'll show you interactive rebasing. You can see how that works. I've actually, I just kind of, a side note, I've talked to like a .NET developer who, we're talking about version control, and it's like, well, how often do you commit and push? And like, maybe once a week. I'm like, no, you're doing it wrong. That sounds horrible. Just one point about using the command line versus graphical user interfaces. So of those of you who are using Git, right, or who here uses Git on the command line? Does anybody use a GUI like Tower or Source Tree or Git? Oh, okay, a couple. So I think this is my opinion, I think, but I think there's a sense that the command line, that using Git on the terminal, is like the right way to do it for like a serious coder. It's fast, it's powerful, flexible, and it is. It's all of those things. But it's not necessarily the most efficient approach for certain purposes, and I'll show some examples of that. One of those is just like having a persistent visualization of your commit history. I mean, you can set up shortcuts or aliases in the terminal, and that can work great if you're like constantly doing that. But with something with a GUI tool that can just be in place all the time and right behind as you're coding. I find that being able to quickly stage not whole files or directories, but parts of files and even individual lines is really quick, much quicker on a GUI than on the command line. That said, the GUIs tend to be really slow and cumbersome at times, especially when you're working with a lot of files. So to me, I think a developer should just make use of a tool where it's appropriate, and not like assume that one's necessarily better than the other. It's just what the appropriate use is. So actually, I'll be switching back and forth between the command line and source tree, which I happen to really like as a GUI, Git GUI. So first I want to talk about staging patches instead of staging a whole file. Let's see, so I want to mirror my screen here. Let's see how this goes. Can you all see that okay? There we go. Okay, so I have a repository here. It's just a README file, very simple documentation. You can look at it, and that's all it is. Just a title and a couple of a subtitle and a couple of paragraphs. So I could add a really nice shortcut with Git is to just add the whole directory with the dot like that, or I could add the README file just to stage it. But if I wanted to only stage the first part, just the headline and the subtitle, I mean, I already went ahead and wrote all this, and then I'm like, you know what? I think the first part should be a separate commit. So We can do that with this add -p for patching, and it brings up this dialog, and you can see that there's quite a few options at the bottom. So if I enter the question mark, you can get this help, and it explains what those options are. So right now it thinks of this whole README file as a single patch. So it's not giving options to. It's just saying, do you want to stage this whole hunk? What I want to do is just stage those the title and subtitle. So if I use this edit option, it brings up this screen, and then I can go in and this is not the file itself. This is the staging interface. So if I just remove these lines I don't want to stage and exit. And now if I look at my status and do a diff on what I've staged, you can see that that's what I've staged. That's a little low. Is that better? Okay. So if I go look at that in source tree, let's see what that looks like. All right, so this is the GUI. You can see there's the staged patch. So I could go ahead and commit if I wanted to. I think I'll come back to it. All right, so pretty handy. So I actually, you know, doing that on the command line can be really handy if you're working on it. I much prefer, as I said earlier, to do that in the GUI. So within this in source tree, let's see. So if I just go in here and highlight those lines, I can stage lines just like that, pretty quick. All right. How many here have done amending commits? Just a couple. Okay. This is actually like a pretty easy and really useful command. Let's go ahead and actually commit that. So I'm going to say add the title and subtitle. Commit it now. Maybe I didn't want to just add the title and subtitle. I changed my mind. Actually, I did want to commit that whole file, so I could just go ahead and add it. And here's my status there. It's ready to be committed. But I don't want to make a new commit. I just want to change that commit that I already made. So if I just run call commit with the amend argument or option, it gives me this option to change the title if I want. Sorry, the commit message. So it's actually incorrect now. So I'm going to say that I'm adding that README file. And now see that I have rewritten that previous commit. That's typically like it's for like you write the wrong commit message or you reference the wrong issue number in an issue queue. So that works great, but it only works for the last commit that you were just working on. And also just beware, you don't want to do that after you pushed it. I'll come back to that point. So the next command I want to mention is stashing. So stashing is a really pretty simple and useful command that when you're go ahead and do some work and then you didn't mean to do that work on the particular branch that you're on, and then you want to just like create another branch and move it over. Stashing can come in really handy. You just stash it and it kind of puts it in this temporary holding place, and then you can reapply that stash. I also find it really useful for dealing with generated or compiled code, like using a CSS preprocessor or with in Drupal with features when you're exporting configuration to code. So I'll show an example of that very quickly. I'm moving into a different repository here. Actually, I'm gonna do this in source tree. That's the other one. Okay, so this repository is called site, and you can see that I have one commit already. It's a SAS file with some generated CSS, and I have some other changes. So this is just the class, and then added a couple of additional sub-elements for like related to that class. And there's the generated CSS right there. Now, if I had just wanted to commit this particular part of it, this name sub-element, and not that link sub-element, using that same patching approach, so I could just stage the lines like this. Now I could go into the CSS file and then stage the corresponding lines like that. But when you have a lot of code in in your CSS or some other equivalent, you don't want to have to go through and search for that. It's just onerous. So a quick way to just generate those changes, the corresponding changes to what I've staged here, is to stash and then keep my stage changes in my working copy. So when I do that, you can see I still have that stash SAS file work, but now those other changes are out of my working copy. They're in this stash over here. Okay, so on the command line, you'd say stash list to see that. There's a previous version, but it's the same thing. So so now I can actually regenerate that CSS file. So like with I'm just doing it directly in SAS, but maybe like use Commits or Bourbon or something like that. You just generate that file, so it compiles, and now you can see that I only have that compiled CSS for that particular sub-element. I can go ahead and commit that. Go. Now I can go back and apply my stash. And I'm going to actually get a merge conflict here. But that's okay. I can deal with this. So if I go back to my text editor and look at my original SAS file as like just a bit of a little white space issue, and I just delete the merge conflict messages. That's what the work was in the SAS file. And also, but in the CSS file, those merge conflicts I don't even want to deal with. So at this point, I just regenerate the CSS. And it's clean, and then I can just stage it. And I've got that second commit with the corresponding CSS. So there's my commit history now. So when you're actually using stash, I think it's a pretty easy command to work with generally.
What is the flag for keeping your partial, like your stage stuff? That's an option in the UI.
I actually never do it on that command line, so I'm not sure. But if you hit man or help. All right. Oh, and also I just learned about this command. I didn't know it, but you can use a stash branch to convert your stash code directly into a branch, which is pretty cool. I didn't know you could do that. Moving on to merging. Just kind of a refresher here, I hope, that there are two kinds of merges. There's fast forward or non-fast forward merges. And typically, I mean, when you're pulling, you have to deal with this. And so a fast forward, so if you're pulling down some commits, just a reminder that pulling is actually a combination of fetching changes from the remote repositories, bringing them down, and then merging those changes into maybe your master branch if you're working on that one. And if you don't have any conflicts, it will just add those new commits and move head up to the latest commit that you've been working on. So that's like a fast forward merge. Non-fast forward would actually create a new commit that's a merge commit that shows that introduction of that where that new code came in. Sometimes you want that, sometimes you don't. Especially, I've seen merge commits for just like pulling everything. So you end up with like hundreds and hundreds of merge commits that are just pulling. They don't mean anything. It's just noise. Also, I want to note that when you merge a pull request on GitHub, it's using a non-fast forward merge as well to create that merge commit. So I mean that shows up in your commit histories and your log, and some of the workflows we'll talk about really leverage merge commits, and others try to avoid them. So just be aware of them. So just a refresher on merging. So we start with one commit on master, so it's the first commit, and then create a feature branch and a new commit on that feature branch. And one more commit on that feature branch, and I'm going to switch over to master and pull down some commits that another developer had been working on. So the master and feature branches have diverged. Now I'm done with working on that feature branch, and I want to merge that in, and you end up with a non-fast forward merge, and that merge commit number 4. Now, in some cases, okay, so at this, I want to introduce rebasing because it's a different approach, and kind of dating myself with the public enemy reference, but check the timestamp, right? The timestamp has changed. And with rebasing, we're going to follow that same approach where we start with commit on master, and I'm referring that as the base commit, and then commits on the feature branch. Pull down those changes on master again, and instead of creating another a merge commit, what I'm going to do is rebase and change as though I'm moving that original commit from number 1 to number 3. So that base commit has changed, it's rebase. And then replay those commits on the end of number 3. And they actually become new commits. And they have new SHA-1 hashes and new timestamps. So you end up with this nice linear history. without that extra merge commit. Warning with rebasing and also with amending is you do not want to rebase commits that exist outside of your repository if you push them. This is a quote from the Git Pro book. So if you follow that guideline, you'll be fine. If you don't, people will hate you and you'll be scorned by friends and family. You end up with duplicate commits on the repository, and you end up having to go and reconcile them, and some of them could be conflicting. You just don't want to get into that situation. Okay, so with that warning aside, a nice flag for pulling is to use rebasing when you're pulling. So instead of creating those merge commits, you're replaying your commits that you've been working on onto that branch. And if that's a workflow that you want to use on all your repositories, you can set that to be the default in the command line or in your GUIs as well. Source tree has an option to do that. All right. Any questions about rebasing, John? All right, moving on to interactive rebasing. So there's a flag -I on the rebase command, or interactive. And this is one of those situations where trying to use a GUI is just kind of a nightmare. It's clumsy and weird, so I much prefer the command line. All right, so going back to this repository, I have an alias just to look at the history. And so you can see those 3 commits that we made earlier. I'll start with a really simple example where I want to just add, I forgot to add GitHub issue numbers to these commits. So I have not pushed these yet, right? So if I call rebase interactive and specify a SHA-1 hash, so it's going to start the rebase based on that commit. I'm using the hash here. When I'm working with like feature branches and develop branches, I'll just say like rebase -I and then developer master, and it'll use the head branch. So you can use either the commit SHA-1 hash or a branch name right there. So when I hit enter, it pops up this dialog, so at first I was kind of taken aback by this. I'm like, I don't know what this does, but if you just read it and follow the directions, it's actually super straightforward, and it's basically a script to rewrite your commit messages, or your commits that you were just that were related to that line and the commit hash that I had given. So it's the last 2. That's what I'm trying to say. So if I just keep the default command pick, it won't do anything, won't change the commit at all. I could just exit right now and it won't do anything. Now, if I change pick to reword, or more concise, to just say R. So I put an R in front of both of those commit hashes. It's going to give me the option to go through these and then reword them. I can also, by the way, I can change the order of these, and so it'll actually change the order that it creates those commit messages. It's basically a text file that I'm working with here. And also, you can even put in your own comments here as well, which is pretty cool. If like you have a really extended interactive rebase and you're trying to keep track of what you're doing, you can comment it in line to explain what you're doing. So anyway, I'm going to go ahead and run this rebase. So you can see it's in progress, and I just want, so this is the commit message, and I'm just going to add a issue number. It's probably 230 did it commit earlier. And proceed. Now this is the second one. And proceed. Now if I look at my history, see that I have those issue numbers and the commit messages. Okay. Any questions about that?
Are you going to talk about the other options in there?
Yes. Okay. So you might have noticed that the comments in that interactive rebase were semicolons. And that's a setting that I changed in Git core because GitHub commit messages start with the pound sign, number sign, and that's also the same character as the comment characters in the interactive rebase. So if I didn't change that comment character, it would have mistaken those issue numbers for comments, and it would actually have removed the line, the commit message. So if you just change your default comment character, I'm using semicolons like a PHP any syntax, then it works fine. There's other ways around it, but this one worked pretty well for me. So so Chris, you asked about some of these other commands. So I'm going to go ahead and so I'm not actually sure how to rebase the very first commit. I never tried that before, so I can't rebase this one, but I'll rebase the previous one. Oh, sorry. I gotta under first. There we go. Thanks. Okay. So I don't know how to rebase this first, just the first commit in the repository, but I can rebase against it. So do that again. I'm going to rename this first commit because what I'm going to do is combine this second commit message into that commit. Commit, not commit message, the whole commit, and the commit message. So this is the squash command. So it's saying to use this commit, don't throw it away, and then meld it into that previous commit. So remember the first option that I chose was to rename. So I'm going to say box name. Maybe I'll just say box subelements. Now this next screen shows that it's combining those commits. So that's that message I just changed. And then below that, this is going to be in the description area, is that previous message. You know, I could edit this if I want to, so maybe I'll just make it like a bullet. And probably do something like this. Put both issue numbers in that summary. Box name. This is a bit contrived, but hopefully it explains like the process. And I'm also going to remove this white space. I don't want to have that there. Okay. Now I let it perform the rebase. Look at my history. Now you can see I have that combined commit. If I go look at that in the GUI, it looks like this. So it combined the code for those two commits, and there's that commit message. So there's that white space, and then the message down below. One note of caution: if you reorder those commits, like I said, you could do. Just obviously, you got to be careful about how they're dependent on each other. If the commits are completely independent of each other, then that's fine. It's not going to be an issue. But if they build on each other and have changes that a previous commit expects, it's going to be you're going to have conflicts. So I find this really handy to kind of like try out things and then go back and squash. Or the other option there was fix up F. That's kind of the same thing as squash, except it just doesn't give you that message. It just like says, just combine this commit into the previous commit and forget about the message. So if you kind of like went down a blind alley with code, but you still committed it, and then you run an interactive rebase, it's like it never happened. It's just all combined into like a nice single commit. So any questions about interactive rebasing? Okay. So kind of going up big picture here, we'll talk about workflows with lots of different branches and some options that are out there. So I think the big name ones are Github Flow, Git Flow, and then kind of just like a million other kind of custom tailored strategies. So GitHub Flow, that's what GitHub uses, obviously. And this is their guide, the URL for their guide. If you just search for it, you'll find it. And they have a nice diagram that shows you how it works. So, they have the master branch, and then you create a branch off of master, like a feature or a fixed branch. Add a bunch of commits to that branch, then create a pull request. There'll be some code review and discussion, and then merge that code back into master, and then deploy it. It's really simple. It's just this straight line. So this is a nice workflow. This is probably what a lot of people who use Git use, or maybe something even simpler, just working on a master branch. And I want to emphasize like simplicity with your version control system is really like the ideal. The more complicated it is, the more it's like taking you away from your actual work of coding. So this is actually see, popped up. Yeah, that works. So this is actually a repository. I was curious if GitHub had a public repository. Well, GitHub itself, the code for GitHub, had a public repository. I don't know. But this is using that GitHub Flow approach. So you can see that they have pull request merges and commit messages from those merges. And so you end up with a history that looks kind of like this, right? So commits and a whole lot of merge pull requests. Okay, so how many people have heard of Git Flow? Okay, they work at Isovera, so it's not surprising. So we use Git Flow at Isovera, and it's a lot more complicated than Git Flow, but it has a really good use case. And one of the nice things about Git Flow is it's the rules for using it are really explicitly laid out. And yeah, it's kind of overwhelming at first, but the key point is that you have your master branch and you have another develop branch. And develop is always ahead of master. So develop is where like new work for like new releases, new features is happening. The master branch is for what's on production. And every commit on it is tagged. Every commit on the master branch should be production ready, like tested and clean. So in addition to those two branches, there are kind of these smaller lifespan branches. So you have feature branches off of the develop branch. And then those are merged through release branches where you have bug fixes and testing, and then deploy to master. We actually kind of don't really use the release branches so much. Sometimes they're handy, sometimes they're not. Sometimes they're just an extra step. And then with security updates and bug fixes, we do a hotfix branch from master. So you switch to the master branch, create a branch off of master with a hotfix, and do some work on that, and then merge those changes. So when we're using with Drupal, we'll have like a core or a contrib module security update comes out. We do the commits on the hotfix branch, and then merge those back into master and also to develop. So we have a repository that I've been working on. This is just a personal repository, but it uses that that Git Flow model, and you can see kind of what it looks like. So there's the master branch, and you can see that it's tagged version 739 and develop branch, and there's also a feature branch with some commerce work that's coming off the develop branch, and it's nowhere near master. So it keeps these branches really separated, and I think the key advantage for Git Flow is that it allows you to have a branch dedicated to the live production site, and then new work that has kind of like it's far ahead, and it's going to change that production site a lot, but it's sort of independent of it. And then you can still like maintain that production site on the master branch, and then move those hotfixes back to your development site as well. And one of the reasons I like SourceTree as a GUI is that it has this feature for using that Git Flow approach. This is already set up right here, so you can see that I can just create a feature branch, a release branch, or a hotfix right through this just pressing a single button. And it's context sensitive. It knows if you're working on a feature branch. When you press that same button, it'll say, you're done with this feature branch, right? And just merge it back in. When I use that same button on a repository that I haven't set it up yet, you can see that it says, okay, let's set up this Git Flow approach. This is just like setting up the naming conventions. It's really, Git Flow is really just a bunch of naming conventions for how you work with these branches. It says, okay, your production branch is called master, your development branch is called develop. It just gives you these defaults, but you can change them if you want. And then it would just say, okay. And then it just adds a little configuration in Git, and then we'll go ahead and work with it that way. So kind of a nice feature. There's also scripts that can do that on the command line as well. All right, so, and then there's just like a range of different workflows. One, I think, interesting example is the OS 10 Homebrew Package Manager. If you go look at their GitHub commit history, you might notice that there's no merge commits at all. It's just a single linear history on the master, and it's just a single branch master. And they're doing this by just rebasing all the time and squashing commits. They have a specific workflow to their process where everything just gets rebased and committed like appended to that master branch. So yeah, generally speaking, I would say, oh, and I do want to say that like we don't necessarily use GitHub strictly, Git Flow strictly speaking, because there are cases where it's not, you don't actually have a development work happening on a production site that's going ahead, and maybe all you really need is a master branch, and you're just doing hotfixes on that master branch, and that's all that's necessary for the project. And just having this extra branch is just extra overhead. Just remove it. So, use a workflow that's appropriate for the site that you're or work that you're doing. And just to like reiterate, commit frequently. If you're going to use interactive rebasing, don't worry about those commit messages when you're first getting them. Just commit, and just something that you can remember. And then when you have a chance to go back and think more thoroughly about them, you could do an interactive rebase or amend and think them over, get the right issue numbers, and squash them together into a nice clean commit. So, and just for further reading, these are some really excellent, like ProGit's kind of like the Bible for Git. Probably might have already seen it. And also Atlassian has some nice tutorials online. And this Git in Practice book by Mike McQuaid is outstanding, and it really covers a lot of the stuff that I covered here. So check that one out. Any questions?
Have you had a situation where you're like, gosh, I'm really glad we're using Git Flow over GitHub Flow, or vice versa?
It's typically the opposite situation where you'd say, oh, I can't deploy this work because these other commits are before it, and it's on the remote, and it's also on the other remote repository, the dual remote. And if we weren't stuck in this linear sequence, we wouldn't be in this position. But yeah, I suppose I should have more gratitude for when Git Flow actually does its job. But I mean, the reason that we started using it was because we'd have clients kind of pick and choose, like, well, we want to deploy this work, but we don't want to deploy that work. That's not ready. And we're like, well, that's early. We have to go cherry pick all those commits. It'll take forever. But having the dedicated development branch with the feature branches off of it allows you a lot more flexibility with that kind of deployment stuff. Anything else? All right, I think we're done. Thanks, everyone.